3/5. How would you solve this problem? Well, remember 4 is the same thing as 4 over 1. Change your division to multiplication and then flip your fraction 5 over 3. And then multiply straight across and you have 20 over 3. So we treat this the same way. You have your feet over 1, change it to multiply, flip your fraction. And so now what happens? Well, you have a feet on the top, a feet on the bottom, so your feet cancel. So you're left with just 2 seconds as your unit. And this, of course, has 1 significant digit, and this has 2, so your least amount would be 2. So here's some more to practice. You can kind of look in your book to see your answers. If you have any more questions about any of these, feel free to email me or come by the lab, and I'll be happy to help you with any questions. Alright, so of course, you know, in this course we have, this is a literacy, mathematical literacy, so of course there's word problems, and a lot of your problems deal with different jobs. So this one, each inch of a cold steel weighs 0.22 pounds per inch. A certain job calls for 27.5 inches of steel. How much would this amount weigh? So you got your 0.22 pound per inch and per, okay, so you've got 27.5 inches of steel and it weighs 0.22 pounds, so that means you're going to multiply it. So you've got 27.5 inches. So go ahead and multiply that in your calculator. You end up with 6.05. Now let's look at our multiplication. You've got pound over inch times inch. So what happens? Well, we've got an inch on the bottom, an inch on top, so those cancel. So you're left with a pound. But remember, with multiplication, you want the least amount of significant digits, okay? So this one has 2, this one has 3, this one has 2, this one has 3. So therefore, your answer only needs to have 2. Well, 6.05 has 1, 2, 3 because the 0 is in the middle. So therefore, you only want 2. So how can I round this? Well, I need to round it right here. Make this just 1, the tenths place. So this is a 5, so this bumps this up to 6.1 pounds. Okay. Some measurements made by technical workers are made into fractions, but many shop drawings are given in decimal form. So the steel rule used in shop or in other technical work usually is an 1/8, 16th, 32nds, or even 64th of an inch. So here are the directions. Your first, so if they were asking for the 32nd, you would multiply your decimal by 32 over 2. Then you would round it to the nearest 32nd of an inch, and then find the error by subtracting the original numerator that's divided by 32. Now there's some good examples of this in your book, section 2.1, so you can also look that up. So let's look at the first example. What is the fraction to the nearest 32nd of an inch equivalent to 0.462? So what you're going to do is you're going to take your 0.462 and multiply it, and just like it says, you're going to multiply the decimal by 32 over 32. Alright, and when you do that, you're just going to multiply the top, and so you're going to get 14.784 divided by 32. Alright, so then this says rounded to the nearest 32nd of an inch by rounding the numerator to the nearest whole number. So you want this to be a whole number. So 14.7 would round to 15 over 32. And then you find your error by subtracting the original from this. So that means you're going to take 15 minus 14.784 all over 32. Okay? And so your error would be 0.216, and then we divide this by 32, and you'll end up with 0.00675. So you would say, you usually round this to the nearest tenth, okay? Nearest tenth of an inch, so, nearest 10,000ths of an inch. So there's tens, hundreds, thousands, 10,000. So right here, so we're going to round this to 0.0068, okay? So therefore, the error involved in using this is 68 10,000ths of an inch. So I'm going to say up here, round to nearest 10,000th of an inch. Okay. Alright. So if it was 64ths like this one, if you were going to do this one, you would do 1.46 times 64 over 64. All of these, 16 over 16. So you would multiply this by 16 over 16, just like I did this problem. Alright. Alright, so here's your homework. If you have any questions again, please contact me or come by and see me in the lab, and I'll be happy to answer any questions you have. And that's it.